This is question 1, paper 2 from the SQA Higher Maths paper 2012. Given a couple of functions, f and g, we're asked to find expressions for these. Well, let's have a look at the first one, and then we'll try and analyze what's going on. So there's the first one, where we've got f of g of x. Now, let's just think first of all what f of x is all about. You can think of these functions as number eating machines where they eat up a number. Suppose, for instance, 2 goes in. It processes it, and out comes 7. So it eats up a number and spits out another number. 2 in, 7 out. If we do it with 3, 3 squared plus 3, that's 9, that's 12, and so on. If we put a in, it'll square it and add 3. So a in, a squared plus 3 comes out. So whatever goes in, then it squares it and adds 3 to it. So that's essentially what the function f does. Feed something in, it spits out the number squared plus 3. So what's going into this function f in this case? Well, g of x is. And what's g of x? Well, it says it's x plus 4. So you're feeding into this function f, you're feeding in the expression x plus 4. There's the bit that we have there. And what f does is squares it and adds 3. So we're taking x plus 4, squaring it, and adding 3. Let's just repeat that. Inside f, you're putting g of x, which is x plus 4. So what does f do to x plus 4? It squares it, brackets are important, and then adds 3. So let's multiply this out and do our firsts, outsides, insides, lasts to get rid of these brackets. So firsts, this term times this term is x squared. Outside 2 terms, 4 times x. Inside 2 terms, 4x. So a couple of 4x's give you 8x, 4x and 4x. And then the lasts multiplied, 4 times 4 gives you 16. So final result, x squared plus 8x, and then the 16 plus 3 is 19. So there's the result of putting g of x into the function f. And the second one, doing it the other way around, this time into g you're putting f of x. And what is f of x? It's x squared plus 3. So into the function g goes x squared plus 3. Now let's get rid of all this rubbish and let's see what g does. So let's putting something into g, it adds 4 to it. If you put 2 in, you'll get 6 out. If you put 3 in, you'll get 7 out. Always adding 4 to whatever is put in. So anything that is put in to g, any number or expression standing for a number, that number will have 4 added to it. So that's all that g does. So in particular, if you're putting if you're putting x squared plus 3 into g, then x squared plus 3 will have 4 added to it. Brackets are not needed here. So that gives us x squared plus 7. So let's prepare for the last bit of this question. Let's wipe all that out and let's copy these answers down. First answer we got was x squared plus 8x plus 19, and the second answer was x squared plus 7. So let's now have a look at the second part of this question. So second part of the question says, show that f of g of x, putting g of x into f, that's what we got here, first part of previous question, and then add whatever you get when you put f of x into g. Well, that was the second part of the first part of the question. So f of g of x we know was x squared plus 8x plus 19. G of f of x, putting f of x into g, we know was x squared plus 7. So a little bit of tidying up. There's a couple of x squared terms there. 8x, and then a 19 and a 7 is 26. So we get a nice quadratic expression for this. It's an equation. This thing is equal to 0. Therefore, this is equal to 0. And we're asked to show that this has no real roots. In other words, we're going into our quadratic theory, which says that if you have a quadratic expression equal to 0, then two solutions, minus b plus square root of b squared minus 4ac all over 2a, and the other solution is x equals minus b minus the square root of b squared minus 4ac all over 2a. Now, the only time you'll have no real roots where you cannot find these two values is if the thing under the square root sign is negative, and that's the discriminant in there. Put a big D there. Big D there. That's the discriminant. And if D is less than 0, then no real roots. You cannot find the square root of a negative number as a real number. So that's you into difficulty. So let's have a look at the discriminant of this equation, whatever's under the square root sign. Now that's b squared. Now b is the coefficient of x. How many x's do we have? B squared, that's 8 squared, minus 4 times a is the coefficient of x squared, that's 2. B squared minus 4ac times c. C is the constant at the end, which is 26. So that's our discriminant. 64 minus 2 4s are 8, 26 times 8. 6 8s are 48, 2 8 16s, and 18, 19, 20. 208 will do. And certainly that's negative. In fact, it's minus 144. Less than 0, so no real roots.